Hello and welcome back to the Building HVAC Science podcast. It's our goal to help create better, more knowledgeable HVAC and building performance technicians by helping these two professions better understand each other. This podcast aims to make customers happy in the homes and buildings they live in and work in. Here's a treat. In this episode, Eric and I are joined by Ross Trethewey, mechanical engineer consultant and a building science advocate who also appears in This Old House. Ross will explain to us, share with us his journey from being a fifth-generation plumber to becoming a professional engineer with a real passion for high-performance buildings. He talks about the critical interplay between building systems and science, and he highlights his work in residential and commercial design through his firm, TE2 Engineering. He also delves into some unique projects, including a World War I lookout tower retrofit. That's something he discusses in the podcast. We transition in the conversation to talking about translating the wealth of building science knowledge into practical applications. And on that note, there are a ton of links I've put together in the show notes that will take you to further learning in some of the topics that Eric, Ross, and I discuss. Ross does talk about the importance of mentorship, sharing these resources and ongoing learning. And he's a big advocate for tools like ACCA Manual J, the Passive House Planning Package, and many others, some of which I've mentioned in the show notes, to help make impactful changes in building performance. So now, let's get into the conversation with Ross, Elk, and I, unlocking building potential. Ross Trethewey on curiosity, collaboration, and innovation.
Hello, everyone. Welcome back to the Building HVAC Science podcast. 2 days after Christmas for a release on this one. So merry, slightly late Christmas to everybody. And Eric Kaiser here, Bill Spohn right over there virtually. And our special guest today, Mr. Ross Trethewey. Welcome, Ross.
How's it going, guys?
Great.
Super excited to be here. Big fans of your guys and big fans of the podcast. So you guys are doing some great work.
And right back at you. Also big fans of yours and everything you do.
Well, thank you. I mean, it's rising tide, raises all ships.
There you go.
It's great.
So for listeners who are not familiar with you, your name, what you do, give us some backstory, please.
Sure. So I'm a mechanical engineer by schooling. I'm a fifth generation plumber. So I've had the experience of seeing it both from in the trenches, summers, soldering pipes at maybe 4 or 5 years old, whatever it was, before the child labor laws got enacted, maybe, and then seeing it from that side, but also seeing it from the engineering theoretical side, getting a master's degree and a bachelor's degree in mechanical engineering. And now I'm a professional engineer. So my day job is designing and consulting on buildings, primarily high-end residential projects. And the name of that business is TE2 Engineering. We also work on commercial projects as well. And so we're designing things in 2 dimensions and 3 dimensions using a variety of different softwares like Revit and CAD. And we are modeling buildings, and we're really getting deep into the weeds on buildings. And we like to do remote monitoring of buildings as well. So we're measuring electrical use, indoor air quality, and a bunch of other things. We can inform those designs to get better at what we do. So that feedback circle is there. My other job is on This Old House as their building engineer. So I've been doing that for about 8 years now. And so trying to bring building science, mechanical engineering, HVAC, trying to bring that to the forefront and try to move it into the next future of all the stuff we talk about every day, heat pumps and building performance, and just trying to take it and really nerding out, getting to that next level where at least trying to pull the show in that direction.
Very cool. That's a big pull on that show. And I've got to say, I've watched that show for years. I used to watch that with my grandfather when I was a little kid.
Me too.
It's cool to get to meet and talk to one of the hosts and interview a host now. I'm nerding out a little bit over here. I'm not going to lie.
A little bit of fanboy syndrome going on, huh?
Yeah, just a little bit.
I get the same vibe when I'm talking with any of the guys. Talking with Tommy or Kevin or Mauro and Mark and the whole group. They're just a good group of guys. I think of them as uncles for me. And being able to have them on speed dial when I have a question about a building, that's been a huge resource for me over the years. But yeah, awesome guys. You're all contractors, all just super good dudes.
You mentioned bringing building science into This Old House. Where does that energy come from? What made you think that's the right thing to do? Was it your hands-on work over all those years? Was it your formal training? Was it something else? What clicked to make you try to do that?
I think it's just curiosity, to be honest with you. I guess I'm just curious about the world and how it works. I'm very mechanical and I understand electronics as well. So having the mechanical plumbing background mixed in with some of the electrical engineering that I did, pull that together, and just being curious about how buildings work. My dad and I always talk about demystifying buildings because everyone thinks about people don't think about the systems of buildings, but it's because it's behind walls, it's behind ceilings. So they don't see it, they're not plugged into it. And so I think of trying to demystify it and learn about it. So my thought is just be a lifelong learner. And that curiosity would just takes me into a deep dive down the rabbit hole on why we did something a certain way, or questioning, should we have done it a different way? Should we use this type of heat pump or this type of furnace or this type of ductwork or this different type of thermostat or whatever it may be? All this curiosity stuff, I think, is really what brought me there. Just trying to figure out why the building works a certain way.
In fact, Eric met you this summer at Building Science Summer Camp. How long have you been going to that and what drew you to it?
I've probably gone to 5 or 6 summer camps now. I'm trying to remember how I first heard about it. It may have been through Steve Basic, the architect. I think he's the first one. It may have been through Coda as well from Building Science Corporation. We do a lot of work with them. But I had been hearing about Building Science Summer Camp, and I was like, all right, what's going on there? But it was invite only. So it was this super secret, what's going on here? So talking with some of the guys in the circles, and they said, oh, yeah, if you want to go, we can get you to go. We can get you in. So then I got plugged in, and then literally it was like just drinking from the fire hose. It was like, oh, my goodness, this place is unbelievable. The knowledge base and the depth at which they would go into these topics. I was like, oh, my goodness, this is where I need to be. And I've gone every year since. It's a must. And so it's on the calendar every year, and just very happy to be able to participate in it.
You also have some really active social media. And I saw one post, I forgot what forum it was in, or you were doing blower door testing on a really tall building.
Yeah.
Want to talk about that?
Yeah. So we get called in for some weird projects, and they're really cool. I keep every day is something new, but that was a old lookout tower from World War One. I think it was built in 1938. Don't quote me on the exact year, but something like that. It's 11 stories tall. It's 16 feet by 16 feet square. Concrete block, multi-layer, going all the way up 11 stories. So it's just shy of 100 feet tall. So the homeowner had bought the property and then built the house next to the lookout tower. And so it's like his hobby where he has guests over and they go up to the lookout tower, and every floor is something different. It's like, all right, this is a bedroom floor, and this one is the galley floor, and this one is the lounge floor. And so it's really cool how the way he set it up. But we got called in because there's obviously some HVAC comfort complaints and some moisture issues and some other things going on there. So we were asked to take a look at it. So what do? We set up all of our gadgets and tools and all the geeky stuff that we can do. And so we did thermal imaging, we did blower door testing, we did zonal pressure diagnostics, just testing how the building pressure was changing as we went through the building. We did a Manual J heating and cooling load on that 11-story lookout tower.
Manual J plus.
Manual J plus, exactly.
It's the tallest Manual J in history.
I was thinking about it. I think Eric had mentioned C-Stack. And I was like, yes, I would love to run that through C-Stack, but I don't even know if C-Stack can go up that high. I think C-Stack, might be maxed out. I think 3 stories,
That could be a challenging one. We might have to drag Steve Rogers in on that one.
Yeah, I think so. Really cool project. And we're working on it right now.
That was a neat project. I saw that video and I'm like, the first thing I thought of when I saw that was, that's like a giant chimney. And holy cow, if that's leaky on the top or the bottom, that is going to be some really big stack effect in the wintertime or in the summertime if it's cool.
Yep. I was actually surprised how it was tighter than I thought it would be.
Me too, when I saw the report, yeah.
I was like, in my mind, I was thinking like, this thing is going to be so leaky and it's going to be crazy. And it actually was surprising. I forget the exact number. I think it was around 600 CFM50. And so I was like, in my mind going into it, I'm like, oh, this is going to be, I was predicting 4 times that in my mind. I was going to say, well, we'll be at least 2,000 CFM50 on this thing, at least in my mind. And when we ran, I'm like, what? That's crazy. I guess in 1938 or whenever they built it, the concrete with the way they constructed it, multi-layered, and all the mud, that I think is lending itself to a much more airtight construction than we thought. There's also not a ton of windows. There's not a ton of penetrations. There's obviously only one door in, and it's built basically on a rock. There's a gigantic granite boulder basically in the basement that this thing is built off of.
That was pretty impressive leakage numbers for an 11-story building, even if it is only 11 foot by 11 foot.
Crazy.
So we're happy to see you interacting more like in the circles that we're in, and great to meet you. And you did mention us before we started recording. You will be at the HVAC School Symposium.
Super excited to be down there. Unfortunately, I won't be at AHR, but I will be at the HVAC School Symposium and doing a presentation down there on air-to-water heat pumps.
Oh, very cool.
Yeah, excited about that. I'm a big proponent of air-to-water. So I love hydronics. That's what my background was. That's what I was taught from an early age. And so we can apply hydronics to buildings and use some cool air source heat pumps to do it. I think that's a big part of our future.
I'm going to agree with you on that one. I think once we get the monoblocks like we're having in Europe right now on the outside and start piping water and or glycol fluid around on the indoors, I think that's going to be a bit of a game changer for being able to do really fine-tuned condition.
Yep. We've been using air-to-water technology for a long time. It's just that now we can unlock the heating aspect that we couldn't unlock before. So we did chillers. We've done chillers for high-end homes, the massive houses that we do sometimes. Those have had chillers for a long time. So we've had those already, but now it's like, all right, wait, we got reverse cycle now, and we can get some heating performance that we really need that's useful to the building. So we could pair it up with radiant floor heat or low temperature emitters inside the building. And so now we've got that synergy of heating, cooling with some domestic hot water from the magic box outside. That's a game changer, like you said. And it's the new refrigerants. They obviously can be self-contained in the outdoor unit. So you don't have to worry about the flammability arguments being made and all the other stuff that we deal with because it's water. Just run or a little glycol in water.
Yeah, and we don't have to deal with variable length refrigerant lines or different, all kinds of weird charges and
oil return, trim charge, like all that stuff.
It fixes a lot of things. I mean, it does introduce some other challenges, but it fixes a lot of problems that we have historically had. So very exciting times in the future.
Do you know Adam Chapman at Heat Geek?
I know of him. I don't know him personally, but yeah, I follow him on the social channels.
Yeah, it just clicked with me that sounds like a logical connection that you should make.
Super excited to see what he's doing over there. And he's pushing the boundaries even more than like where I thought it would be, where he's trying to get away from buffer tanks or like reducing the size of buffer tanks. Because that was always the challenge was with air to water, you needed the buffer tanks to store that volume, give it the thermal mass, and give it the run cycles that the heat pumps need so they don't short cycle and other things like that. So he's trying to push the boundary to say, hey, let's reduce the size of that buffer tank, or in some cases, get rid of the buffer tank because we have enough volume in the system to be able to keep that. And then the part of that is getting unlocked because there are now variable speed compressors that can throttle themselves way down. So the amount of BTU input into the fluid is reduced. So the volume and the flow rate through that system can be reduced.
That's very interesting. So thinking about the multiple uses of components in the system.
And also space, too. Space is a premium in these houses. And so if you have to put a big buffer tank in with some circular pumps and all that jazz, it just takes some space. And so it makes the hurdle to get from air to air to air to water that much greater.
Where do you do your work? Where do you get called to do your work?
We're primarily New England based. So we're licensed in all the New England states plus New York. So that's our bread and butter, the Northeast corridor there. We occasionally will go outside of the territory for unique projects, but in general, we try to stay in our sweet spot here in New England.
We got a little bit about you in the books here now. Let's transition this over to another conversation that I've been wanting to have and have been thinking about for a while. How do we take all this knowledge? Because there's a ton of building science, HVAC, construction in general knowledge. And there's a lot of new knowledge coming out as we're seeing more and more people studying these things. And how do we really take all that and go from concept into a project and make sure that it's applied well to a project from one end to another? Because as you talked about before we were getting on the show, like there's a lot of people that are really good in very specific things, but trying to get all of them to come together and make that work together, that's a big challenge.
It is a big challenge. And we haven't really solved it yet, I don't think. I think there's still a lot of work to be done there. As you guys know, buildings are complex. And so there's a lot of different systems that are interacting in and on that building. And so we talk about moisture management, we talk about water control, we talk about humidity management, we talk about temperature control, we talk about the other things like mean radiant temperature. We talk about all these things and they all affect each other in some way, shape, or form. And so to get that right, it is complex and it's going to be multidisciplinary. And so the way I always frame it is that you could have the best HVAC contractor and the best HVAC system on the planet. If you have a bad enclosure, if you have a bad building, there's no system that's going to work to meet expectation and meet comfort in that house. And so the fact that we have these different silos, different disciplines that all need to interact and work together synchronously to make sure we have a positive outcome for that building, that's the challenge with our buildings. But that's what also makes it so much fun. It's tricky, but that's what's fun about it. If it was easy, everybody would be doing it. It's why we're here.
And sometimes just giving a name to that might help, because then you can codify it and share it. We're just spitballing here, but what would you say would be like a person like yourself who understands the building?
I call myself a building engineer.
That sounds like the guy that works on the elevator.
I know. It's a horrible name. I don't have a name. It's a hard one because, like we just said, it's complicated. It's building based. So the systems of buildings, I wish I had a good name for it. I think people default to building science.
Yeah.
But building science sounds scary to a lot of people. And it sounds like too complex for the average homeowner, contractor, et cetera, to understand. Like you mentioned the word science, you lost a lot of people at that point. So I feel like I wish there was a better word that basically pulled it together. Building science it's good, but it could be better.
We know house whisperers, we know energy doctors, we know home docs, things like that. There's a lot of different business names out there, but it's almost like if the awareness isn't there and you can't call it something, it may get glossed over, it may get missed, may not be communicated. What I think, if I have like a little longer tail in this industry than both of you, maybe even combined, I don't know. I hope not that far yet. But sharing success stories, communicating, actually sharing failure stories is important too, because there's a lot of learning built into that. Is there a project that you work on where you don't have to consider the holistic aspect of the building?
Never.
You won't let it happen.
Yeah. I mean, if you take your eye off the ball, you'll make the wrong choice or you make the wrong decision and then the outcome obviously will be affected. So it's like everything affects everything. And I always tell our folks that work with me that you have to be eyes open and not jump to conclusions that you think may be the case. Like you got to do your checks and balances. You got to do your homework. And so buildings always surprise you. The lookout tower is a perfect example of that. Like my guess and my estimate was completely wrong for the air leakage of that building and how it was going to perform. But the cool thing about we can measure it. And I always say the data doesn't lie. So if we capture that data, we capture accurate data, and then we look at it, that will lead us, in my mind, that's the way that we get to the promised land. That's how we know that we're doing a good job, that we have that feedback loop, that we are providing the right systems for that home at the end of the day.
When you say do your homework, to me, that means you study, you reflect, you pull resources. What are some of your resources? Including training and experience that you have. I mean, that's also a resource. It belongs to you, but it's a resource.
There's the formal training that could be all the way through from podcasts to college education to continuing education credits through Coffee with Kalefi, as an example. It's a webinar series that's focused on hydronics. There's all of these resources now. Back to Eric's point, we have so much technology and so much education now that we didn't have before. You used to have to go to a physical class to get the class to learn. And there's nothing wrong with that. And that's still tremendous. That's a great way to learn. But we don't need to necessarily do that. We have YouTube. We have all these different webinar training series now available to us. So yeah, for resources, there's all of that. There's obviously ASHRAE. There is NFPA. There is a lot of the manufacturers put out their own trainings that we attend. We just came back from the LG air to water heat pump training. As a staff, we took our entire staff out to their Westboro, Massachusetts facility to get trained on their new air to water heat pumps that are now released in the US. So I think a combination of hands-on training, webinar trainings, building science summer camp, all of that stuff. So we have that, but then we also have the tools. So we have blower door tests, thermal imaging cameras, smoke testing. We've got obviously manometers. We have anemometers. We have sound testing. Yeah, I mean, here, I got devices here. Here's Retrotech's new Solo. Here's air gradient. Here is a new Reed's sound testing kit. Actually, this just came from you guys.
Look at that.
It's a Testo.
417 sitting on his desk.
417 anemometer. And that's coming out of a This Old House studio segment that I'm working on acoustics, on HVAC acoustics and what makes HVAC systems loud. But yeah, so like I think about using all of these resources that we have available to us to continue to learn and use the tools to apply them. And then we model stuff. We use RightSoft. We use Revit. We use Beopt. We use Energy Plus. We use a variety of different softwares to do whatever we're trying to do or trying to calculate for that building.
It sounds like there's no one linear path. You sort of have to cut your own way through this field. And like you and Eric have discussed, there's a lot of resources available. But I think it goes back to your statement a few minutes ago about curiosity about the world. You can get all you need, but you have to go find it.
I wish there was a curriculum and a very straightforward path that could take you through that. Have you guys been to any of the building science symposiums through the BS and Beer group? Have you guys heard about that?
No, heard about it, but not been there. Yeah.
Same.
So those are 2-day live trainings. And over the 2 days, they're trying to talk about the building envelope all the way through to HVAC. Again, it's a 2-day training, so it's jam-packed, but it's a start of putting together a linear path for education to take people through. Let's get the water control layers right. Let's get the air control layer right. Let's get the vapor control layer right. Let's get insulation right. Let's do that. That's all day one. Let's get the building envelope right. And then day 2 is all about HVAC, indoor air quality, and everything else that's going on.
One of our previous podcast guests, Enrico Bonalori, is offering a passive house training in different cities around the country. If you look him up on LinkedIn, I'll put the link in there. But getting training in passive house doesn't mean you have to build passive houses, but it does bring together all those interrelationships that you mentioned of all those factors.
Yes. I always think about like the theory and like the concepts are tremendous. Like you said, even if you're not building a passive house building, you can still apply the concepts there to make a building perform better.
You probably know the Pretty Good House folks.
Of course.
Yeah. In the book that they wrote, and that's the same idea, is that there's a scale. There is the ultimate, but anywhere you move upwards on the scale, you are probably doing a benefit to your customer and perhaps your reputation.
Yeah, for sure. That is a great book. And that's a great, exactly as it sounds, Pretty Good House. It's like, hey, maybe we don't have the budget or the ability to get all the way to this amazing like thermal enclosure, but guess what? We can start to move up that scale to get to a better building and do that in a smart way.
Another, I'm spouting off here, but slow me down if you want. But we had Ellison Bales on. We interviewed him last week for a podcast and actually had published today, this morning. He has a book called A House Has to Breathe or Does It? That is a really, I think, a friendly written book that brings together all these factors that you mentioned. And it isn't a curriculum. It isn't part of a course. Neither is a Pretty Good House or Enrico's class or Building Science Summer Camp. But although Joe does teach like a 9-session course, something like that, you can take remotely. I'll find that and put a link in there. But these resources are out there.
I think that's 4 classes.
4 classes. Okay.
So you're right. These resources are available. Allison, I've read his book. It's an amazing book. I remember when I first got into the industry, Residential Energy by John Krieger was a book that I had read way back when that I thought was a solid step on residential energy and where the energy losses in a building and how the energy flows within a building. So there are these amazing books and these live trainings and online webinars. So there are way more resources now than there ever was previously. So we have this at our fingertips now.
There's that knowledge level we've got. And in your engineering, and then I'm sure you work with some other architects around the area on new builds or even retrofits and things like that. We have all that knowledge, and now we're going to take it. We got to apply that knowledge out here and put it to work. And I'm seeing that's where I guess people are maybe struggling a little bit more. We have all that knowledge, but in some ways, I wonder if there's maybe an overabundance of knowledge that's being put out in some ways, and people hit overload through all of these different avenues. At some point, we got to take it all and we've got to put it to work and we've got to make things happen.
Yep.
What point do you think we really maybe switch from learning? How do you know when to switch from learning more to putting that knowledge to work?
It's a great question. I would never say that too much knowledge is not good. And I don't think that there's too much knowledge out there. But I think there's also the analysis paralysis type of mentality, I think, where the type of person that's craving all this knowledge, then just basically just feeding off of all this information. But then when they actually get to let's say a home comfort consult, they're at a building, they're at a house, and they're like, wait, should I go look at the HVAC? Should I do an air leakage, a blower door test? Should I go look at the windows? Should I go up at the attic? Should I look at the water control, what the condition of the shingles are? They get faced with all of these questions and all these thoughts pop into their head. And so it would be tremendous to almost have a roadmap that contractors and people could follow to say, like, here is your checklist, and almost like a flow tree, like if this, then that, and try to move down. Does the building have this? Okay, yes, then move to this step. And so you can almost bring them through a sequential checklist to basically make the best use of their time to get the most critical information and data from that building to be able to make informed decisions for that homeowner. I hear all that too often where they're like, oh, I changed all my windows. I upgraded all my windows, and their energy bills barely changed, if any. They might have gone down small percentage. The ROI on that, it's not really there. It's not really there. And if you think about in a lot of these older homes, there's different costs to upgrade that building. And typically Windows is not where I'm starting. And a lot of people start with things like that, and they don't get the ROI that they were expecting coming out of it. There's a pecking order in my mind of items that I like to see, or at least to verify and check that we can move on and get that building performing better.
Yeah. If you're in business, you got to stay in business. You have to do business to stay in business.
Yeah.
And I'm by no means saying that we should stop learning new things, but I see that there's like you said, the analysis paralysis or the learning paralysis. I've suffered from this. I've realized that I don't know what I don't know, and that drives me to go learn new things. But at what point I've had to start to realize, at what point do I really say, okay, I know enough to actually go do something now? And I feel like that with the disjointed, I won't say disjointed, but the large number of different sources of information that we have today. To your point, like with a curriculum, it is, okay, somebody has looked at this and said, this is at least the base knowledge that I need to go do something. You get through that curriculum, start to finish. That's the base level. That's what I need to go start doing something, and I can go do something. But I think it's really hard for people to look around at all these different resources and say, okay, now I know enough to go do something, and I know enough to go accomplish something and have a good outcome when I get done with that something.
A big part of that is confidence. I think taking the initiative to say, okay, I've learned something, I'm going to now go apply it and have the confidence to make that leap. That's hard, especially for a contractor that doesn't want to get it wrong. The last thing you want to do is get it wrong. That's going to be an unhappy customer, unhappy client, multiple phone calls to get back there. So there's the do no harm principle is key there. And I think that prevents a lot of people from making that step or making the leap to go venture out into that next discipline within the building. There's also, I think, something to be said about mentorship. And I think for anyone that wants to actually get into the weeds, I know like we've had some people reach out to us and we've said, hey, tag along on the next site visit. Come join us. You could just be eyes and just watch and see what we do and how we talk and the lingo and what tools we're using and why we're using them. And we've had literally complete strangers on a couple of our site visits just watching what we do and asking questions. And so we've tried to provide some mentorship to some degree. And I also want to say that the forums on Facebook and on other social media platforms, those have been great because let's say someone does take the leap. They have the confidence to go do something that they haven't done before, and they come across a challenge. It's been amazing to see people take photos or videos and then basically post that in the forum. And then all of a sudden, before you know it, 30 people have provided the answer to their question. And that is powerful. It's like, wait, I have this whole group, 500 people in this forum. They're all experts or decent experts here that can all provide insight. And they probably have come across this type of issue before. That provides that feedback loop, but also gives them more confidence to go out and do more work like that. And so I think social media, when used right, can be a huge resource for a lot of us.
And you might not be aware, but Eric's aware, I'm working with some people founded a nonprofit called Better HVAC, which would be a directory of resources.
Great.
So that'll be rolling out in about January, but do that same thing as put in one place. Because a lot of times the forums and the posting on Facebook, for me, are so hard to search, to find something. You saw a nugget, and then 2 weeks later, you want to go back and grasp that. Unless you've screenshot it and properly noted it away, it's gone.
Yeah, that's a great point. Those nuggets do get lost unless you screenshot it or write it down or whatever. But the Better HVAC is that what's the output file going to be like? How will you interact with it?
It's going to be a website, but with a directory of resources by topic area.
So you could search.
Yes.
Got it.
And then pointing to those resources. So,
well, thank you.
Oh, you're welcome. Seeing the world the same way you do, and Eric does, is that there's so many things you can get paralyzed and spend a lot of time researching, and then sometimes shrug your shoulders and give up and never gain that confidence to take the next step again, second time, feel burned.
Yeah, for sure. I also think about it too, I remember from school, we always talk about model sensitivities. What parameters in the model are going to make a difference in the output of that? And so in our world, let's say Manual J, let's take that for a ride for a second. If I change a certain parameter, let's say that I'm really curious, are these 0.32 U factor windows or 0.31 U factor windows? When I run that load for analysis for a room, it may change the load by 100 BTUs. So you could spend an amazing amount of time and research and diving deep into that to get that model as accurate as possible. But at the end of the day, the value proposition isn't there to spend that much time to change the outcome of a room load by 50 BTUs or 100 BTUs. That number is not enough of a order of magnitude for it to make a difference in the heating and cooling system selection or the airflow selection or anything like that related to that building. We want to know what parameters move the model, which ones have the most sensitivity to it. And so your blower door test is a big one. So air leakage has a huge swing on the Manual J. So that's the one we need to make sure we get it right. So identifying what are the ones that have the most sensitivity to a model in this example, or have the most sensitivity to anything, those are the ones to focus on. Those are the big levers that we want to make sure that we're getting right.
Something I became aware of when we were designing our house was something called the Passive House Planning Package.
PHPP, yep.
Yeah, which it's a very intricate modeling program for those that aren't familiar with it, and allows you to vary these parameters, as Ross is speaking about, to see the sensitivities, to see what makes a difference, and see where the loading area, the checklist of where to put your money in terms of probably of a new design. That's where most of your flexibility exists. But in existing construction, you have to deal with the deck that you're dealt.
Yep, that's great. And I know the RMI, the Rocky Mountain Institute.
Oh, yeah.
They're coming out with a couple different calculators that are going to try to get at exactly that for, just say, you have a regular single family house built in 1950. What are the things that I should be looking at to upgrade that building and try to give that roadmap like we were talking about? And it takes in a bunch of information that you input, like climate location, climate data, age of construction, and it's going to start so taking the minimum amount of inputs and trying to give you maximum output in terms of where you should focus your time and money.
Mm-hmm. That's going to be a fantastic tool, because I think that's one of the really hard things that people struggle with, especially on retrofit housing, is where do we put that money? And of course, as you mentioned earlier, a lot of people will start with windows because they can see those. That's a very visual thing. And sometimes you want to put windows in because the new windows make something pretty or they make it look better. And that's fine. But admit to yourself when you do that it's just for looks. It's not going to be for a performance other than looks. If it changes that room BTU load, as I tell people, unless your curtains are blowing when the wind blows, your windows probably aren't going to help you much.
It's so true.
That's making that low-hanging fruit decision. That's going to be an awesome software, it sounds like.
Yes.
We covered a lot of ground on our conversation here today, and you probably have more models to work on here, even though it's a Friday and you've got things to do. So as we wrap up, I'd like to have you share your closing thoughts on this topic or the topics we discussed with our listeners.
As things move forward, we have more technology at our fingertips, more resources to use. And I think the more that we can do collectively to try to bring that information to the forefront and make it digestible, easy information to follow, to look up. I think Better HVAC and what your initiative is there is tremendous. The stuff that we're doing with This Old House and obviously in our business with our consulting stuff, and we're going to start to put more social media stuff out there, trying to raise the tide, as we say, to raise all boats. So super excited about where this is going. There's a lot of complexity. There's a lot going on. There's a lot of new technology, but super excited about where it's going.
Fantastic. Got to thank you for spending the time with us today to record this podcast, and look forward to seeing you in person at HVAC school. I'll be sure to put a link in the show notes on that one. Hey, Eric, have you checked? Is there still live passes available?
I have not looked to see if there are in-person tickets available.
While he's looking that up, thank you for having me on. This has been great. Appreciate it.
Appreciate it. Thank you. We'll stick a link to the HVAC School Symposium in the show notes for anyone who wishes to attend that or see the virtual sessions too.
It looks like there might still be tickets available.
Fantastic. As of this recording.
As of this recording, that's going to be another week before this releases. So get online and take a look. But Ross, I appreciate you coming on, and it's been a lot of fun.
Thank you for everything you do.
Thank you, guys. Yeah, that's great. Thank you.
Thanks again for listening to this episode of the Building HVAC Science podcast. We hope you learned a few things from our conversation with Ross on curiosity, collaboration, and innovation. Some of the topics we discussed require technical training for proper interpretation or safe execution. So if you're a trained pro, you can proceed immediately. But if you're not, please consult with and hire a trained pro. The Building HVAC Science podcast is a production of TrueTech Tools Limited. In full disclosure, I am the owner of TrueTech Tools. The opinions expressed are those of my guests, my co-host, or myself, depending on who is speaking, of course. And if you're in the market for any tools or test instruments that we mention, or things just in general, sort of in our line of what we offer, our curation at TrueTech Tools, TrueTechTools.com, TrueTechTools.com. Take a look at what we carry, and you can use the offer code HVACBS for a nice discount. Thank you for listening to and following us on Building HVAC Science. You can always reach out to us and contact us through marketing at TrueTechTools.com, TrueTechTools.com. We appreciate you, appreciate your feedback, appreciate the comments we get from time to time. It's really an honor to be doing this podcast and be speaking with such great guests like Ross. Until next time, take care.